Hello and welcome to MechLearn 360. So in this video, I want to solve a problem with you to illustrate the concept of a force which is in space. All right, so let's solve the problem together. So I have two forces applied. Two forces are applied to an eye bolt as shown. So that is the eye bolt here. We are to determine the x, y, and z scalar component of the force F1. And then we should express the force F1 as a vector in the Cartesian form. All right. And finally, we should determine the angle alpha between F1 and then F2. All right. So let's do this together. So the first thing to do is to assign convention positive, positive, and then positive. So what we want to do is that we want to walk along the axis, and then every distance that we are going to move in this direction is positive. In the direction of the arrow is positive. Finally, in the direction of the arrow is positive. If I walk against the arrow, then that is negative. All right, so let's start with the F1. So how am I going to be able to resolve this force into, in other words, get the x, y, and z component? So what I will do is that this is F1 multiplied by lambda. So what this means is that technically, if I want to express this force into space, I would have to multiply the scalar, which is what, 900, and then multiply it by a unit vector in this direction. So I'm going to actually walk. Let's call this say point B, and let's say this is point A. Then it means I'll walk from A to B. In that sense, I would actually let's describe first of all a position vector. All right, that will help us to find the unit vector. So what I'm going to do right now is I'm coming to walk from this point to B. First of all, I will have to walk in this direction all the way upwards here. And the distance is going to be 3 plus 4, which is 7. And it is along this direction. So we are saying that this is going to be 7k. Then I will walk from here to here. And that will be against the direction of the x. The distance is 6. So minus 6i. Finally, I will step down in this direction. And that is the direction of the y. It is going to be positive. So plus 3j. So if I rearrange this, I'm going to get minus 6i plus 3j plus 7k. And that is actually the position vector. Now, if I actually want to get the force in space, I would multiply this 900 by the unit vector, which is going to be minus 6i plus 3j plus 7k. Then I will divide this by the magnitude of minus 6 squared plus 3 squared plus 7 squared. And this is actually the unit vector I was talking about. In other words, a vector divided by its magnitude. So vector F1 is going to be, let's pick our calculators and do this together. So 900 into minus 6 divided by square root of minus 6 squared. Sorry. So minus 6 squared plus 3 squared plus 7 squared. And then I would put this in brackets. What is that? So I'm going to get minus 556.967. Minus 556.967 I. And then I would do the same thing for the j components. I would change the numerator and make it 3. That is going to give me 278.484. So 278.484 j. And then finally, I will change this to 7. 649.795. So plus 649.795k. Now, if I have been able to do this, then what this means is that this component is the x component plus this component is the y component plus this component is the z component. In other words, fx is actually minus 55.69 point 55 minus 556 0.967 if I want the scalar component, that is it, and this is actually in pound. Okay, now let's not forget that this is in feet. The position vector is in feet. All right, now the y component is also 278.484 pound. And then finally, the z component is 649.795 pound. However, if I do this in the IJK form, then that is what we call the Cartesian form. So I have been able to solve part A and part B together. I need to solve for part C. But before I can find the angle between force F1 and F2, I need to also resolve F2. I need to also resolve F2 into I, J, and K components. Now let's see how to do that in the same approach. So let's assume that this is, say, C. So I will describe a unit vector from A to C. All right, so first of all, let's assume that I want to look at the, okay, so this is what we are saying. I want to express F2 as a vector. And so I'm going to multiply the scalar by a unit vector. But first of all, let me do a position vector. That will help me to get the unit vector. So if I want to walk from A to C, I will do a distance here. And this corresponds to this, which is 3 plus 3, so 6. And then it is along the positive y direction. And so it's going to be 6j. Now from here, I will do a distance here. And that is also 6, but it's going to be against the x direction. So minus 6i. So minus 6i. And finally, I will have to climb up in this direction, positive, and it's 3. So that is going to be 3k. So plus 3k. So if I rearrange, then it's going to be minus 6i plus 6j plus 3k. And then this is actually in feet. All right. So I've been able to do this. It means that if I want to express F2 as a Cartesian vector, then it's going to be 900. Don't forget that F2, oh, sorry, F2 is 700 pounds. Sorry. So I will do 700 multiplied by the unit vector, which is going to be the vector divided by its own magnitude, minus 6 squared plus 6 squared plus 3 squared. Is that right? Now let's pick our calculators one more time. And then this time around, this is 700. And then this is what? So minus 6. Then I'll divide by the, so minus 6 squared plus 6 squared plus 3 squared into brackets. And what is that? I'm going to do minus 466.6. So minus 466.6 I. Then I'll change the numerator and make it 6. But it's going to be the same. The sign will only change. So plus 466.6 G. And finally, I will change the numerator to be 3. So if I make it 3, then I'm going to do 233.3. So plus 233.3. Okay. And if I do this, I've been able to express this force. This is actually in pound. I've been able to do this and express this force. This is also in pound. But this is actually the Cartesian form. If I want the scalar form, then Fx is going to be minus 466.6 pounds. And then Fy is going to be 466.6 pounds. And then Fz is going to be 233.3 pounds, and that is it. Now at this point, what we want to do is we want to find the angle between the two vectors, and the geometrical property for doing this is what we call the dot product. If I know the dot product between two vectors, I can find the angle between the vectors. So from the dot product, I can say that the dot product of f1 and f2 should be equal to the magnitude of f1 multiplied by the magnitude of f2 cosine alpha, which is the angle between f1 and f2. In other words, cosine alpha is going to be f1 as a vector multiplying or dotting f2 as a vector and then dividing it by the magnitude of f1 multiplied by the magnitude of f2. Okay, now I want us to do this together, and so let's take our time. We want to do the dot product. So when we say the dot product, what we will do is that when I take this I component here, then I will dot it with the I component of this. In other words, I'm going to actually multiply the I components and put it at one point. Do the same for the J and do the same for the K. All right, so let's do it together. So if I take the I component of the first one, I have what? Minus, so I have minus 556.967. And then I'll multiply this with the I component of the second force, which is what? Minus 466.6. And then I'll put this at one point. What is that? 259880. 259880. 259880.80. All right. And then I'll add it to the second part, which is taking the Y component of this and then multiplying it. So let me do that one. So 278.484, and then I'll multiply this by the Y component of the second one, which is what? 466.6. Is that right? And I'm going to do 129940. So 129940.63. 129940.63. And finally, I'll do the Z component. So I'll do this one. And so let's do it together. So it's going to be what? 649.795. And I'm going to multiply this by the Z component. So this one, which is what? 233.3. What is that? 151597. 151597. And then this is actually 0.17. Okay, so 0.17. Okay, then I will divide this by multiplying 700. So 900, then 700. All right, so let's do this on our calculator and equate it to cosine alpha. So let's take this into our calculator. By the way, let me add, or let me just do it. So I have 259,880.80 plus 129,940.63, and then I'll add it to 151,597. That's right, 0.17. And I will divide this by 900 multiplied by 700. And the answer I'm getting is 0.859. 0.859. And so alpha is going to be cosine inverse of 0.859. And what is that? So if I take the cosine inverse of this, so cosine inverse of 0.859, then I'm going to get what? 30.79. Or let's say, yeah, 30.8. So 30.8. And that is actually the angle between F1 and F2. So our problem has been solved. Thank you very much for watching.